All right, how's it going? So, gonna do a review the next 2 days. But if you got questions, let's start with those. Otherwise, I'm just kind of going to go through the whole quarter in review, which isn't very exciting. All right, we'll do a non-very exciting thing. So final exam is, technically for this section, the final exam is Wednesday at 11. If that really doesn't work for some reason, the other section's final exam is Monday at 10. All right, and I don't really mind if you come to one or the other. I only made up like 35 copies of the exam for the A section, so I might have to go and make some more copies if you decide to come to that one in great numbers. But if that works better schedule-wise, you're welcome to come to either, but not both. The two exams should be basically the same difficulty-wise. Someone from the other section asked if I was going to make the second one harder since you got 2 extra days to study. But no, they should be basically the same as far as what they're covering. So only difference is the time that they're offered. Very similar to the midterm, but there's going to be more questions about Linux. Okay, so there's going to be, it's 100 points, half of that is programming, so 5 programming questions. The other half is all going to be short answer, fill in the blank kind of questions about Linux and things related to Linux. Hour and 50 minutes, should be plenty of time, okay? But pace yourself accordingly. And the usual 8 pages of notes, single-sided, 4 pages, double-sided, whatever you like. So, basic topics, right? So, know how to do things in Linux, okay? Because there is, a few pages of short answers. So, you know how to use echo, right, to output something, read to input something. I didn't put anything on here about if statements and all of that. I need to put that on. Oh yeah, that's later. So cat is used to show the contents of a file or to copy standard in to standard out. Copy is for making a copy of a file. Move, MV, is for renaming a file. RM is for deleting a file. Right, so basic operations. LS lists the contents of a directory. LS-L shows you more information. OD shows you the contents of a file in a different format, so you can examine things like executable files or JPEGs and stuff. WC is a word count of a file, and so on and so forth. So all the stuff that you've been using throughout the quarter working in Linux, you should be comfortable with those by now, right? All right, standard in, standard out, standard error. Standard in is where programs read from when you say fgets or getcar or things like that. And normally it's your keyboard, right? So normally WC counts the number of words, characters, and lines in its input, right? So if I WC my .bashrc file, it tells me it's 225 lines long, right? If I say WC without a file name, it reads from standard in, and it tells me that my input through standard in had 3 lines, 4 words, and 18 characters. Right? And a lot of commands, if they take a file name and you don't give it a file name, it just reads from standard in instead. Cat does the same thing, and so on. So if I let's make a test file. So if I say word count file, it does word count on file. If I say word count, it comes from standard in. If I say word count less than file name, it's saying take standard in from that file. So it's going to do the same thing as just word count file. If I type a command and I pipe that into word count, then standard in for word count is whatever standard out is generating on the command date. So this will do a word count on date. All right, so 1 line, 6 words, 29 characters. That's what date produced. And so the example we've seen is like ls pipe into word count tells me there's 59 files in my directory. 1 per line. So standard in normally comes from your keyboard, right, kind of by default. But if you use this less than sign, then standard in is basically read from this file. And if you type some command and you pipe it into CMD, then standard in is whatever the output of C1 is. All right, so cat file shows me the contents of file. Cat less than file shows me cat reading standard in, where standard in is coming from this file. If I said cat file and I pipe that into cat, this is saying cat command should read the contents of file, send the output to standard out, and the second cat command standard in comes from the standard out of that first cat command, so this just shows me the contents of file. And instead of sending that to standard out, I can pipe it into cat, and this will do exactly the same thing. So weird stuff like that. So standard out is the output side when you say printf or puts or put car, right? Your output goes to standard out, which is normally your display, but if you say command greater than, then standard out gets written into this file instead. And if you say command pipe into some other command, then standard out is copied over into standard in of this command. And so that's ls pipe into word count, for example. And we may or may not have talked about this, but if you do 2 greater than signs, that means append. So if I just keep doing this, each time I do this, the contents of out is replaced with the output of the date command. So it shows you the date command last time that I ran it. If I do greater than greater, that's saying execute the date command, take standard out, and append it to this file out. And so now if I look at out, it's got all of those output lines. And I can type apparently 3 times per second. All right, quotes. So there's 3 kinds of quotes we deal with mostly. There's double quotes, there's single quotes, and then there's back quotes. Okay, double quotes really don't do anything except group stuff together into a single thing, right? Right, if I say x equals this is a test, I get a complaint from the shell because it tried to set x equal to this and that it tried to execute some command called is, and it doesn't know what that means. So if I put this as a test inside quotes, it sets x equal to that thing. It sees this as a test as a single thing, even though it's got spaces inside. And if I do single quotes, it does exactly the same thing. So if I do x equals hello $ variable by, right, we know the $ will take the value of variable and it'll replace $var with that. So if I echo the value of x, it's hello ha 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 by. But here if I do single quotes say everything inside here is literal. So that $var is just $var. So this one makes things literal in the actual sense. And then back quotes say execute some command and replace all of this with whatever this command generates to standard out. So the classic example I always use is d equals back quote date. And so d is equal to the output of the date command. Right, so I can set d equal to ha ha, back quote date, ho ho, and since I've got spaces, I'm putting the whole thing inside double quotes, and it does what you would hope. So I just replace the back quote date with the output of the date command. And again, if I do single quotes, everything in there is literal. So d was equal to ha ha space back quote date, back quote space ho ho. So single quotes, if you really just want to explicitly say, here's what I want you to use, right, without doing any substitutions or evaluations. Double quotes go ahead and they evaluate $, they evaluate back quotes, and so on. All right, so what is a shell? We've been using a shell for 11 weeks, so you should know, and you used it all through 121, right? So a shell is a program that basically reads from your keyboard typically and performs actions at your request. So it runs programs, it displays information, it manipulates the file system. Mostly it runs programs, right? Most of what you do is executing programs. Right, so RM is a program sitting under /bin. When you say remove a file by saying RM space file, you're running a program /bin/RM. And it picks up an argument from the command line, which is a file name, and then it does some stuff to remove the file. Right, so mostly a shell is just executing files for you. But more generally, it takes commands from you and it does what you ask it to do. So the shell we use is bash. That's the only one we've been using. So what is .bash rc about?
.bash rc is like the configuration file.
Yeah, so it's a configuration file. Linux. So I'm sitting on the Linux server right now. I'm running a shell called bash. There's a bash rc file in my home directory, usually. And all of this stuff, it acts as if I type this in when I start up a bash shell. So the first thing I do is see if I'm root, and if I am, I set my prompt to a number sign. Otherwise, I set my prompt to a command number inside curly brackets. And I set up an alias so I can type QA and it means this stuff. And I set up an alias for GCC to turn off warnings because I'm a sloppy programmer, and so on and so forth. There's an awk command I use when I want to look at your source code from ODPs. It goes through the log file and it pulls out. The log file contains, your name and how you tried to run your code and what the output was and what the differences were and so on. It also includes a copy of your source program. And this is an awk statement that pulls out just the source code lines from the log file. And so I can use this to really quickly go through and just sort of look at the source code you've got And if you're having problems with the ODP and you tell me about it, I can just say extract, put in your name, and see what your code is, and then I can figure out what to tell you. So that's set up when I log in, right? I can just say extract, and it executes this big, long, ugly awk command that otherwise I would have to type every time that I wanted to look at source code. So it's a way to do things that we want to do every time that we log in automatically. All right, shebangs. For us, it's generally this. First line of the file, okay? When I run a script by typing the name of the script, the shell looks at the first line, and if it begins with a number sign exclamation mark, it will run my script through whatever that program is. If that's not the first line of the file, it will run my script with a copy of whatever my current shell is. So if I'm running C shell and I type in the name of a script and it doesn't have the shebang on the top, it will execute your code through the C shell. If you wrote your code to be executed by bash, I'm going to get syntax errors. So you can force it to run through bash by putting this in the very first line of the script, and even though I'm in C shell, it'll see this and say, oh, this is a bash script. It'll start up a bash process and it'll feed your code through it. And it's got to be the first line. So sometimes people add comments to their scripts at the very last minute before they submit them. And so there's a comment block in the top, and then about 10 lines down, there's the shebang, right? It doesn't work the same way if it's not the first line. So it's just a trick that the shells use. Otherwise, it's just a comment because it starts with a number sign. All right, and aliases, let us replace one command with another. So we can say alias new equals old. Right, so hello is now an alias for echo hi. So if I say hello, it says hi. But if you got a big long GCC line that you keep typing, right, I can type that big long GCC thing and I can set up an alias for it, go. And now when I want to compile my program, instead of typing all that or using the up arrows to find the last command, I can just say go, and it'll go ahead and execute that whole command. So it's another convenience. And if I'm doing this a lot, I would probably take this and put it where? Put it in your .bash RC. And now I don't even have to type this line every time that I log in. This is all set up for me. And you got to do it once. You got to go in and you got to say vi.bash RC. But once you set it up, right, every time you want to compile, you just say go. And these things make your life longer. All right, so aliases. Processes. So main things to know about processes, right? When we're running from the command line, there's sort of two areas. There's a foreground and there's a background. Thanks. There's a foreground and there's a background. So if I just say command, it starts running in the foreground. Okay, and my keyboard basically feeds into this, and standard out basically goes to my display. And this is the way we normally execute commands. And normally bash is in the foreground. When we say run a command, this command is now in the foreground. So if this command is something like let me close my, if this is something like VI, right? VI now has control of my display and is listening to my keyboard. And if I say print working directory, right, bash is not going to print my working directory. This is the thing that's in the foreground right now. And when the command exits, it goes away and bash comes back to the foreground. But if I say command with an ampersand after it, that command runs in the background. So sleep 100, that's a foreground command. Bash is not listening to me. Sleep 100 ampersand, that's running in the background. Bash is still listening to me now. So I got bash in the foreground, I got sleep in the background. I do a sleep 200, that's in the foreground. Okay, if you're running a command in the foreground, you can say Control Z, and that suspends your command. So I can Control Z, and now I'm back to where bash is listening to me, and this sleep command is just kind of hanging out in limbo. So I can say BG to push the job into the background. I can say FG to push it into the foreground. So if I say BG, now it's running in the background. And I can say jobs at any point and see what's currently sitting in the background. I have two jobs, they're both running right now. And I can bring this first job to the foreground. And now that's my foreground job. I can Control Z to suspend it. And if I look at my jobs, job 1, which was sleep 100, is stopped, right? It's not dead, it's just suspended. Job 2 is still running. And I can bring job 2 to the foreground. And I could kill that. And now I've only got job 1, right? So from bash, from the command line, we can manipulate jobs. We can basically move them between the foreground and the background. Foreground, it's got control of our keyboard. Background, it's kind of running in the background, right? So it's doing its thing. We'll let this poor job finish. It's doing its thing, but it hasn't taken over control of our keyboard effectively. That's the way it appears, at least. Okay, there's different things going on. So my sleep 100 finished after 100 seconds, and now there's no jobs in the background. So we can move things back and forth, right? But basically, Control Z suspends, FG brings to the foreground, BG to the background. Job shows you which jobs you have, and we can kill a job with kill. Okay, the more interesting part though is with fork. Bless you. So what does fork do? If we call fork. It makes a copy of the current process, right? So you call fork, and when fork returns, you now have two copies of your process running in parallel doing the same stuff. And they're exact copies with one difference, which is the return value from the call to fork. Okay, so what's the return value tell you? Whether it's the parent or the child. So how do you know?
The child returns 0.
The child gets a return of 0. The parent gets a return, which is the process ID of the child. Okay, and if those are not totally clear, you jot it down on your note sheet, right? Because you could do it either way. But the way it's done, parent gets the ID of the child gets a 0. All right, and then typically you take that return value and you do one of two things depending on whether you're the original parent or the cloned child. So we talked about other things, but I'm not going to test you on them. We talked about exec, we talked about popen and dupe2 and all these other constructs that we can use for building up multiple processes that do different things. I'm not going to test you on those, but you will probably see a question about forks. So review those. And same thing I told the other class, right? So if stuff that we're going through here is not registering, or you're fuzzy on it or something like that, right? Spend some time and mess around with it a little bit, right? If you don't know exactly what fork does, write a program that just calls fork, prints out the return value, and see what it does, and it'll jog your memory probably from when we talked about it, or, you know, if it just makes no sense, I have no idea what's going on here, it's totally confusing, just ask me, right? Shoot me an email or catch me before Friday's over, and we can go over it. Okay, file systems. So file systems are hierarchical. There's a root to the file system, which is slash, and there's directories that sit underneath. And each of these things can have directories underneath them. And so there's some symbols we use for directories. We can use a period to represent our current directory, and we can use 2 periods to represent our parent's directory. So where am I right now? Okay, so I'm in my PA4 directory. If I say ls dot, right, that shows me what's in my current directory. Dot just means my current directory. If I say ls dot dot, that says move up 1 level from where I am. That's going to show me the contents of my programming assignments directory, which is all of this stuff. If I say ls dot dot slash PA1, that says move up 1 directory, that's programming assignments, and then come down to PA1. So this will show me programming assignments slash PA1. But these things like dot slash a dot out or dot dot slash PA1, they're relative to where I am right now. If I'm sitting here and I say dot dot, I'm referring to the home directory. If I'm sitting here and I say dot dot, I'm referring to the USR directory. So these are what we call relative path names, right? They don't absolutely define a fixed location on the system. It depends where I am when I'm using this. Now if I say something like, I really wrote a backslash, that's horrible. If I say something like slash home, slash test, right, this says start at the slash, the root directory, go down to home, go down to test. This absolutely refers to this directory. Okay, so this is called an absolute path, relative absolute. Yeah.
So if you were sitting in log with dot dot and bin? Or
Yes. Yeah, so dot dot is always 1 level above wherever you happen to be. And then the slashes just mean, you know, move in that direction. So if I say ls dot slash dot, right, that's just my current directory. It says go into my current directory, and from there look for my current directory, and from there look for my current directory, right? It doesn't do anything. Right, so this just keeps moving you up. And if you try to move above the root, you just stay at the root, which is that. So hidden files. So what's a hidden file? File that starts with a dot. Right, so I created 2 files, haha and .hoho. If I do ls, I see haha, I don't see .hoho. If I do an ls-a, it'll show me the things that start with a dot. And it's just a convenience that lets you create files that you want to have in a directory, but not burden the user with seeing them every time that they do an ls. Because we have all these things like .bashrc that we need to have around when we use git, we have these .git directories. And it's a pain if every time you do an ls, you see your two files and then 50 other dot files, right? So by default, ls won't show you those because there's a whole bunch of files that start with a dot, especially in your home directory. And it would be a pain to have to deal with those. So they're called hidden files, but they're really not any different from other files. They're only hidden by the way that ls works. So permissions, right, are these flags in the front of an ls, and they basically say what different entities can do with a file. So there's three groups: read, write, execute permission for the owner, for the group, and for everybody else in the world. And you can give or take away these individual permissions. So RW dash means that I can read and write the file, people in my group can read and write the file, and everybody else can only read the file. All right. And we use this change mode command to set these individual bits, and we just use a 3 octal digit code that corresponds to those 3 bits. So the usual one we use is 755, which will turn on read, write, execute for the owner of the file, and then just read and execute for everybody else. So that's how we make our files executable. And this is persistent, right? I can make changes to my file, and it's not going to modify these permission bits, okay? The permission bits are like the name of the file. They don't change on their own, which is why you only need to do that change mode command for a script one time, right? You can edit the script, and you can go away and come back the next day. You don't need to say change mode again. It doesn't do any harm, but it doesn't do anything either. Right, if I copy a file at 755, the file that I copied into also is 755. So it kind of keeps track of stuff like that. But if I start a new file, right, by default that comes out 664. So I can't execute that. All right, links. So so here's a file that exists. I'm going to create a link to it. So ln-s, s says symbolic link. The file that we're linking to, and then the link that we want to create. So I'll call it my link. So now I've got 2 files in my directory, my link and old file. And if I cat my link, it's got the contents of old file. If I make some changes to old file, and I look at my link, it shows me those changes, right? And the reason is that my link is a link to old file, so whenever I do something to my link, it's going to do it to old file. So if I edit my link, I'll be editing my old file. If I edit old file, I'm effectively editing my link. And if I get rid of old file, my link is still there, but when I try to cat it, it'll say no such file. Right? My link is there, but the thing it points to, that's what there's no such file or directory anymore. So if old file reappears, my link just points to whatever's in that file. All right, so that's a symbolic link. It's the only kind of link I'm going to ask you about. There's also hard links, but I'm not going to go into those because we don't do them very often. But review your notes on symbolic links, ln-s. And then all things variables. And again, you've been doing this throughout, so none of this should be too shocking. Right, this sets x equal to a string containing two characters, a 2 and a 5. Right, x equals high, sets it equal to two characters, an h and an I. This sets x equal to 3 characters, a 2, a plus sign, and a 3. So if I echo $x, it's going to say 2 plus 3. Okay, if you want to do arithmetic, throw this $paren around your expression. No spaces anywhere. Okay, this will set x equal to 5. Ooh, having typing issues. There we go. All right. So that's the whole difference there. All right. This may work, this may not work. Okay. I'm going to say don't use spaces inside $paren. If you do, I will type it into bash and test it. And if it doesn't work, I will take off many points. No, I won't, but I'll take off a point. Don't use spaces inside here. Okay, when we talk about ifs and whiles, right, put spaces in where we've been putting them in. And it just makes things less wonky. Now I really want to break this somehow. Okay, maybe it likes spaces. What else can I tell you in here? Okay, so built-in variables, $1, $2, $3, etc. These are the arguments to a script. Okay, so if you run a script, $1 always shows you the first argument after the name of the script. So if your script is, whatever your script name is, this is fun, right? $1 will be equal to this, $2 will be is, $3 will be fun, $4 will be blank, $50 will be blank. Okay, $number will be equal to 3 because it counts how many arguments you have. That's different from argc. Okay, when you write a C program, argc in this case would be equal to 4 because argc also counts the program name. Yes?
Is $0 equal to go?
Yes. Is that your question? Okay. Yeah, so quick check. I can just echo $0. It's bin bash because that's the program I'm running right now. All right, but again, it's an argc difference versus $number. $number is the things after the file name. Argc includes the file name. So no cheat note. $** is all of this stuff separated by spaces. So it's a single argument, but it includes all of your arguments. $? Shows you the results of your previous command, right? So you use that all over the place in Zenity probably. And $$ we didn't really talk about, but it's just your process ID. So 22693, that's my bash process ID. That's what $$ is. You don't really need to use that for anything we're doing these days. So exports. All right, so here's a program that just shows me the value of my variable x. All right. I said x equal to hello. I say show me the value of x, and it tells me x is blank. Right? This is because when I run a script, it starts as a new process. A new instance of bash is created. And when you create a new instance of bash, you start with kind of a clean slate. So here I said x equals hello, that's in this bash shell. When I say go, it creates a new bash shell with a clean slate. None of these variables have been defined. So when I try to show the value of x, it's blank, because nothing in that bash shell has set up x. So if I want my x equals hello to be present in this new shell, I can basically make it global by saying export in the name of the variable. And now when I say go, creates a new bash shell, but it will copy over everything that I've exported. And in this new shell, x will be equal to hello, so my script says x equals hello. And this is why you have to do that one export when you first set up Zenity. Right, so that when you run Zenity, it's got access to this directory information. So exports kind of make variables global in a shell context. All right, so Zenity. You know how to use Zenity. You've used Zenity. You've done beautiful things with Zenity. What do I want you to be able to do on a test? Basic dialogues. So if you know how to use the entry, the calendar, and the info options, you're good. Okay? And the main things we do with this is something like Zenity -- entry, and we can type some stuff in here, and it spits it out, right? If we want to capture that to a variable, we can use our backquote trick. So set x equal to backquote, and then our Zenity command, and then whatever we type in here, that becomes the value of x. Okay, if you got that down, you're probably good for Zenity on the exam. Okay, I'm not going to ask you to make a 3-column list and put in radio buttons and all this kind of stuff. Basic dialogues. Okay, I'm not going to hold you responsible for dealing with the \r stuff or suppressing error messages or all of those details. Okay, I'm looking for low-hanging fruit here. And you've just spent weeks on Zenity, so that should be pretty fresh. You should know how to compile a C program. All right, so GCC. Even if you don't do this on your own, you should know GCC-O. So -O followed by the output file. And then all the other stuff that you normally put in the .c files, a -G if you're doing GDB and so on. But instead of making an a.out, it makes an output file, right? And then you can just type, and that's automatically executable if there were no compile errors, and then you can just type that file name and execute your program accordingly. So GCC-O, the -G option is used to include debugging information. The -C option does what?
Creates object file?
Yeah, it just compiles, creates an object file, right? So it will leave you with a .o file. It doesn't get you all the way to an executable, which is useful because sometimes your programs don't contain a main program, right? Sometimes you're just writing a file that has a super-duper getcar function in it, and you don't want to try to build that into an executable, so you use the -G switch. Right, so I can compile this up and I get my sub.o. If I just try to compile sub.c, right, I'll get the horrifying messages from the linker saying there's no reference to main. Because when you say GCC or GCC-O, it assumes there's a main program somewhere called main. And when it got to the point of trying to build the executable, I couldn't find it. So we do the -C switch to say just make an object. And it ties into make files, which we'll talk about tomorrow, and -G ties into GDB. So yeah, a few more Unix things to go through, right? GDB we've talked about for the midterm. Makefiles we'll review. tar you've been doing from the beginning. We'll refresh regular expressions, awk and sed. Bash programming, I think this is exactly the same as it was for the midterm study guide, because we didn't really learn anything new about bash after the midterm. And then C programming is pretty much the same as on the midterm study guide, but I added in the file commands, fopen, fclose, and so on. And I think that's the only thing that was new. Oh, and some of the C-type stuff like is space, is upper, stuff like that. And the rest of it I think is basically the same as what was on the midterm study guide. So we'll run through the rest of Linux and the programming stuff tomorrow, but it's mostly stuff we've already covered and you've already seen on the midterm. So, make sense?
Are you going to include for loops on for bash programming?
Yeah, so bash programming, there's while loops and there's if then else is, but no for loops. You can use them if you know how to use them, but I don't think we've ever talked about for loops in here. So you can put them together out of whiles. All right, so I'll see you tomorrow.